A very good day, dear students. So I'm back with one more exciting session. But this session is going to be a little bit of break, a very little break from our daily robotic sessions. And because this session is going to be a very important session about a very fundamental topic, and that's very important from your examination point of view. So this session is basically named as the session on AC generators. Now, why AC generators? We all have studied AC generators in our class. We all have studied AC generator from our books, from our course books, textbooks. Now, the principle that guides the AC generator is a very simple principle called Fleming's right hand. Okay, so let us first see what the principle is, and then I'm going to show you an animated video to make the concept a bit more clear, to concise the concept, the huge writings of books. Okay, so let us first focus on what is Fleming's right hand. So to begin with, from scratch, let us see what Fleming's left hand rule was. Fleming's left hand rule was basically called the motor. Why the motor rule? Because the motor, that's a device which basically converts the electrical energy to mechanical energy, is based on this principle. What did it say? It said that there are these three fingers, okay, which are mutually perpendicular to each other, and this represents the direction of electric current flowing in the circuit or in the coil. Basically, this represents the direction of magnetic field from north pole to south pole, of course. And this gives the direction of the force experienced by the current carrying conductor. So this was the Fleming's left hand. Opposite to that, by opposite, what do I mean? By opposite, I mean the representation, the conversion of energies of this, the Fleming's right hand rule, is basically called as the generator. Why the generator rule? Because it is used in generation of electricity. So in left-hand rule, the motor rule, what we are doing, we are converting electrical energy to mechanical energy, like our electric fans or any kind of motors. In Fleming's right-hand rule, what we are doing is we are converting the mechanical energy into electrical energy. That means we are doing is basically generating electrical energy. And that's why it is also called the generator rule. In When we have a power cut or something like that, we basically use a generator to generate electricity. And this is what the principle is based upon, Fleming's right hand rule. What does it look like? It looks like something like this. If you point out your forefinger like this in a straight, and if it points in the direction of the given magnetic, what is the direction? From North Pole to the South. Mind it, the direction of the finger is from North Pole to the South Pole. If you point the thumb towards your motion, what kind of motion? The motion that you are providing, the mechanical energy, the direction of energy that you are providing. Okay. So in this case, if you point out your middle finger in perpendicular, mutually perpendicular to both the fingers, it will give you the direction of current. Same as this one, right? Same as this one. It's just that in Fleming's left hand rule, we give the given quantities was these two fingers and the output was the force. But in this case, Fleming's right hand rule, these are the given quantities and this is the output that we are getting, the current. Clear? So that is where the generator, principle of the generator lies. Now, how does an AC generator looks like and how does it work? I'll be showing you an animated video and I'll be making you understand. So students, this is an animated video. You can get it easily in YouTube. Okay. So this is an animated video which will demonstrate you the how does the generator looks like and what can be the schematic diagram that you need to draw in your examination to fetch full marks, of course, and how does it work. Let us have a look. This is how from the external structure the AC generator looks. Okay. Now if we dissect it, if we go into it, then how would it look like? Let us see. This is how it is basically looking like from inside the basic mechanism of it. Okay. Now I'll be explaining it. Do not worry. See the working principle first. What is the working principle? Fleming's right hand rule. Okay. So this principle is based on the theory called electromagnetic induction. And dear students, what does electromagnetic induction stands for? By using magnetism, by using the property of magnetism, how we can generate how we can induce electricity into an electrical circuit. And by electrical circuit, I mean only a conductor which is not carrying current, and we are giving the current by the property of induction. Okay, so let us see the process. How does it basically looks like? Okay, so during the motion, can you see while we are moving the magnet, the magnetic field, the magnetic flux is getting intersection. It's intersecting with the conducting wires, and that is how the electricity is being generated over, right? So that was the principle with which it basically works. That is electromagnetic induction. So I hope you have understood it, the principle of electromagnetic induction. Now let us see how does it work. So this is basically the principle on which it is based upon. Okay. Now let us see parts of AC generator. If you see, that is the armature coil. Okay, so the armature coil is basically the main part. We can say the coil, the conductor that we are providing through which the current will run in the circuit. Okay, then comes, can you see the blue and red parts, the two poles of a magnet, right? No pole can be a single pole, of course. This is a shaft with which we are providing the motion, with which we are rotating. That means with which we are providing the mechanical energy. Okay, this is how we rotate. Now the vision must be very clear how it works. Okay, that is why I'm showing you the video, animated video. Now with the circuit, can you see over here? With the circuit, there are two rings connected. Okay, so let us see the different parts. Now these highlighted parts are the magnets. These are the slip rings. Remember, these are not split rings. Split rings are used in DC motors. Slip rings are what we use in AC generators. Okay, this is the exact structure that has been shown. All right, and can you see the brushes connected to it just for electrical conductivity purposes? These are the brushes. All right, this is how the circuit is complete. Here we have connected a galvanometer, of course, for the direction and the production of current. See it to visualize. Okay, all right, this is how the construction. Let us focus on the working of this generator. Visualize it, see it very carefully. This is how the armature coil we are rotating. And can you see the blue lines, the magnetic field lines from North Pole to the South? Okay. So can you see the interaction of the magnetic field lines and the conductor over here? That is how the current will get produced over, right? That is what is called the induced EMF. Okay. Now, in which way, how the current is getting produced? Let us have a look. Okay. See, this is the first position. Let us take this the position 0 from where the movement starts. Okay. So this is the first position. Can you see maximum amount of magnetic field? It is being passing the flux amount of flux crossing it. The area cross sectional area is maximum. Okay. So in this case, the induced EMF will be minimum because the maximum amount of flux is passing through it. The more we change the angle between the induced between the current carrying coil, or not current carrying, I should say, the coil and the magnetic field lines, the more there will be the induction of current. Let us change the angle. Let us, now we are changing the angle, mind. Now at this position, can you see Can you see, dear student? Let me remind you this. This is the position where the whole of the magnetic field gets interacted with the coil, the full armature of the coil. Okay. So in this position, the maximum EMF would be induced. Let us see. I'll show you a graph. Okay. This is how we are rotating the armature. All right. Now, can we apply Fleming's right hand rule over here? Can we apply it? Magnetic field to be in this side. Okay. The motion, if you are giving in the downward side, the part of the coil in which the motion is in the downward side, can you apply Fleming's right hand rule over here? Can you see the current, the direction of current is outside the screen, the plane outside the screen. Okay. And opposite, in the opposite arm, can you see it? This is how it works. In this arm CD, can you see the flow of current is in that direction? That is why this visualization and animation is required. Okay. Now, can you see with each turn, the galvanometer, it will be deflecting in a different direction. The same arm AB will experience the current flow in a different direction than the previous one. If you apply Fleming's right hand rule in this arm AB and continue to apply it when it rotates by 180 degrees, you will see the direction of current is reversing itself. That means the deflection of galvanometer, can you see, is in the opposite direction. All right. And that is why the AC current is being produced in the simple generator. Okay. The reversal of the polarity. Now, this one is a very important part. Why? It is a graphical representation. So we are starting from T equal to 0. That is maximum flux crossing the cross-sectional area. Okay. Remember that. Now, if you see the graph, of it, we'll be noticing. Let me just increase the speed a bit. Okay. Now, can you see? We'll be starting the graph from T equal to 0. Okay. And we'll be taking the angles as T by 4 in the time range to be T by 4, T by 2, 3T by 4, and finally T. Okay. Let us see how the graphs change. With that motion, 90-degree motion, can you see the induced EMF reaching to its peak, the maximum value? This is the maximum range that can be reached. Okay. Now, with again the angle increasing and the flux increasing, the value will keep on decreasing. See, the value is decreasing, and it will again become 0 when the magnetic field lines is perpendicular to the plane of the coil. Okay. See, it becomes 0 at T by 2. Again, it will increase, but dear students, mind it will increase, but in the opposite direction, and that is where we have put the negative direction. It is going in the opposite direction, so we take it as a negative direction. Can you see? We're taking it as a negative direction. Again, it is the peak value that we have reached in this position. Okay. Again, the value will decrease to 0. Again, the value will decrease to 0. This is how the wave looks like. This is how the AC current representation, graphical representation looks like. Okay. This is what we have learned in this whole module. Okay. At the structure of an AC generator, the principle behind it, okay, and how the AC generator basically looks like and how it works. So again, the principle is a very simple principle called the Fleming's right hand rule. Dear students, you all know it. Okay. If you don't know it, let us remember it in the form like father, mother, children. For children, C, it represents current. For mother, M, it represents the magnetic field line directions. And for F, in this case, F represents force, but the resultant of force that we are taking, that is motion. No motion can happen without a force. Okay. We all know that. But in this case, motion is the most important thing. Stationary magnet or stationary magnetic flux, stationary magnetic field lines won't produce or won't induce any current in the coil. So continuous motion is required. Okay. So I hope you found this session interesting. This was the very simple session, very simple explanation of the working of an AC generator. So I'll be back again with some other explanation of DC motor or some other important topics. Till then, have a nice day and see you again. Thank you very much.